Hey, welcome back. So as you probably know, in 2024, one of the biggest trends in AI is the emergence of agent platforms. If you don't know what an agent is, it's essentially AI that can make autonomous decisions. So rather than you telling the AI specifically what to do, you give it a goal and then it uses the right tools and its own thinking processes and reasoning to be able to solve the problem. And one of the best known patterns in AI today is what's called the ReAct pattern, which is based on chain of thought, and it's this idea of reasoning and actions. So essentially, you get the agent to think about what it needs to do to solve the problem, and then it will use any particular tools it knows about to then make executions. Now, why this pattern is so powerful is that it gets to use things like tools. So you can define tools such as maybe a calculator or a clock or Python, for example. And therefore, rather than just reasoning, it can lean into those tools to solve those particular problems. And of course, that solves problems today like AI struggles to count, so therefore it can use the calculator. It doesn't have an up-to-date knowledge base, so it can use tools such as the browser to go and be able to get the most recent information using things like Google, or, of course, using any other tool to solve a particular problem. So today I'm going to break down the ReAct pattern, and I'm going to do that using Langchain. So we're not just going to execute it, but we're going to look at how it really works step by step underneath the hood. And before we get under the hood, what I'm going to show you is a very simple agent that I built earlier, which will get you the current time using the system time tool. And then throughout this video, I'm going to show you how that actually works step by step. So if I just run the script, the actual system prompt that it has is what is the current time. So if you see here, it's going to have a look at this and says entering a new agent execution time. It sees the thought process. I need to check the system time to answer this question. And then here's the action. Remember what I said about reasoning and action. So it's reason that needs to check the system time, and then the action is going to call this tool called check system time. Here's the format, and then it says I now know the current time, and the final answer is 2024. 13th of April, 16:10:20. And again, if we actually just look at the Python script underneath that for 1 second, you can see here I am using GPT-4 as the model. Of course, I'm using Langchain as my framework here. The query is, what is the current time? We'll talk about what this prompt template is in a second, and then I'm using this tool check system time. Again, I will go into those details a little bit later, and then I'm going to construct this ReAct agent. I'm going to create my agent executor, and then I'm going to execute the agent, passing in that query, what is the current time, and then it will go off and execute that call. And again, if I run that one more time, you will see here, this is where it does the reasoning. So I've asked it the question, what is the current time? And then there's the reason I need to check the time. There's the action. Remember that tool check system time that I said before earlier. Gets the format of what it needs to pass in for the the time zone, etc., or the date time format, passes that in correctly, gets the result back from the tool. Now it's 16:11, and it says the current time is 4:10. So let's break down how this actually works. So to do that, we're going to use Langchain. So Langchain is probably one of the best tools for being able to work with agents. So if you haven't got Langchain already installed, using Python, you can just do pip install a Langchain, and then that will get you installed. So as you see, I've already got that installed, so there's not a problem there. The other thing that I will want to install is I am going to use OpenAI. I'm going to use GPT-4 for my agents just now. In another video, I'll cover how to work with other LLMs, but for just now, we're going to use GPT-4. So I need to do a pip install a Langchain dash OpenAI, and that will give me the OpenAI APIs within my Langchain framework. So once I've done that, what I am going to need to do is I'm going to need to pass in my OpenAI API key. So to do that, I'm just going to do a touch.env. I'm going to do a .env file. You can, of course, set your variable in memory and use it as an environment variable, but I'm just going to create an env file here. And then all you need to do is go to platform.openai.com, and then you can click on API keys, and then of course you can create a new key from there. Once you've generated that key, you just need to paste it into the .env file. So if I open this up in Visual Studio Code, we open up the .env file, what you would do is set OpenAI API key equal to, and then just paste in that value. I'm obviously not going to show you what my API key is, but that is where you would paste this in. Alrighty, so what we're going to do now is I'm just going to get you a little bit comfortable with using Langchain. We're not going to use agents just yet. We're just going to ask some basic queries. So I am going to create ourselves a new file. I'm just going to do a touch hello, and we'll call it langchain.py. So now that we've got that, well, let's just open up in Visual Studio Code, and then we'll start writing some Langchain. So actually, the first thing that I'm going to need to do is I'm going to need to access my environment variable. So I'm just going to do a from.env, and then I'll do an import load.env here. You will need to do a pip install.env if you want to use .env in the same way as I have. Now, the other thing I need to import is I'm going to need to import some Langchain modules. So I'm going to import Langchain core.messages, and specifically, I'm going to import human message and system message. Again, we won't use that later on, but I just want to do this for this very simple Langchain example. And then the other thing I'm going to need to import is going to be chat OpenAI. So once I've done that, I just need to import my environment variables. I do that by doing load_.env. And then I need to pick the LLM that I'm going to use. So I'm going to say LLM is equal to chat OpenAI, and I'm going to set the model is going to be equal to GPT-4. Now, if I want to, within platform.openai, I can use any of the models within my account. So if I click on here, playground for a second, you will see here model, I'm using GPT-4, but if I wanted to, I could use the new GPT-4 Turbo, I could use GPT-3.5 Turbo 16K. Basically, I just need to put whatever the model name is as my LLM in my Python code, and it's got to basically be the same name as in this list. The next thing I need to do is I need to set my query. So we will build up to the what is the current time. For just now, I'm just going to type in who is Katy Perry. You can probably guess from my Katy Perry in the background, for anyone who's got a keen eye, that I'm obviously a big fan of Katy Perry. So now what I need to do is pass in both my system prompt and my user prompt to GPT-4. So to do that, I'm going to create a new array called messages. And in that, I'm going to pass system message. And I'm going to set my system prompt to being something like you're a helpful assistant. Now, of course, I can set that to be anything, but I think that will just do for just now. And then I will set the user prompt as human message, and I'll set the content is going to be equal to the query. So in this case, it is going to be who is Katy Perry. And then all I need to do is execute my LLM. So I'm going to do result equals LLM dot invoke. And I'm going to pass in my messages array. And then finally, I'm just going to print out the result. So if I now save that and we come back into my terminal, and if I run Python hello Langchain, you're going to see it'll take a second. I've not enabled anything like streaming, but it's going to go and make that call to GPT-4. It's going to ask the question, who is Katy Perry? It's going to come back with a big answer. And there it is. So you can see Catherine Elizabeth Hudson, known professionally as Katy Perry, is an American singer, blah, 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 blah. So there you go. That's your basic introduction to kind of Langchain. So one of the things you might have heard of with frameworks such as Langchain is this concept of prompt templates, where you can set a template for the prompt that you want to send and then just inject the variables that change, which again, this is really useful for if you're asking specific who is questions and you just want to put a different person's name in all the time. Maybe you're looking up a database or whatever, then that's a good technique to be able to do that. So we're going to convert the Langchain that we just wrote, which was kind of more chat basis, and we're going to move that into the prompt template type format. So to do that, I'm just going to remove this from Langchain core.messages, and instead I'm going to import a couple of things. First one going to be the from Langchain underscore core.prompts. And then that is going to give me access to this prompt template, which I am going to import. Once I've done that, I can get rid of that messages piece, and then I can write prompt template is going to be equal to prompt template dot from template. And then I'm going to write in who is, and then I can pass in whatever I want. So in this case, I was using Katy Perry, but this is going to be my, my template in general. So always I'm going to have who is whatever the person's name is. And input is going to be essentially the substitution variable. So in this case, I can now change the who is Katy Perry in my query, and I can just make that as Katy Perry. Now, the next thing that I want to be able to do is execute this. So there's a couple of other changes that I will need to do. I'm going to introduce this concept of chains. That's going to be really important later. So the first thing we will do is we're going to have an output parser. And at the moment, we're just going to deal with things like strings. So we will just set this to be stir output parser. As you can see, I've got some nice squigglies there. So I need to do another import. So I'm just going to say from Langchain underscore core dot output parsers, and then I'm going to import, and specifically I'm going to pick stir output parser. Now, as you may have noticed, there are other types such as JSON output parsers. Again, but for simplicity's sake, we're just going to use string for just now. But again, as you explore Langchain for yourself, you may want to use different parser types. And we're going to use the Langchain's built-in chaining mechanism. So I am just going to pass in prompt template. I'm going to pipe that with the LLM, and I'm going to pipe that with output parser. And then essentially now when I want to do my result, rather than doing an LLM invoke, I can invoke my chain. And now I can pass in the input, and that is going to be set to the query. And now I can get rid of the messages, and then I can just put in some brackets here, and I will pass in input, which again is the substitution variable here. So I'm going to set input, and I'm going to make that equal to query. So I am essentially passing in Katy Perry and input. So if you think about what's going on, I'm doing a chain invoke. The chain is being made up of the prompt template, the LLM, which is GPT-4, and the output parser, which is the string output parser. And then, of course, this chain here is just going to combine those items. It knows what to do with them. So when I call the invoke, I'm going to pass in the data that I want to be combined with the prompt template, executed LLM, and then outputted using the string output parser. It will execute it via the invoke, and then it's going to come back with the result. So now if I just run my hello Langchain again, you're going to see I'm going to get the exact same result. It's going to say who is Katy Perry. Gives a different answer because of course it always does. But the nice thing that I can do here is if I want to change this, and rather than say who is Katy Perry, I can just substitute this with who is Taylor Swift, run that one more time, and there you go. It's came back with Taylor Swift as an American singer-songwriter. Now, this is all very great, but the problem that we have with this technique is only interacting with the knowledge that the model has. I'm not interacting with anything external to the model. So if, for example, the bio of Katy Perry or Taylor Swift has changed over time, it's not going to have that latest information about those folks. To do that, we would need to either have the model updated with latest knowledge, or I would want to be able to use tools to go and ask a larger ecosystem. And that is really what we're going to be doing here with agents. We are going to combine the knowledge that the model has from its own knowledge base, and then we're going to use tools to augment it with knowledge from the outside world. And to demonstrate that, we can actually come back to Langchain for a second, and we can get rid of the who is Katy Perry. We'll keep with the input, and now we will actually ask it what is the current time. So this is coming back to the example that I showed you at the beginning. So now if I run that, you can see GPT-4 is coming back saying, as an AI, I don't have the ability to provide real-time information, including the current time, so it doesn't know. And the reason it doesn't know is in order to access the time, you need to access a tool of some sort that has the answer. It's not going to have the time from its knowledge base because time is a moving thing. And this is where agents come in. So what we are now going to do is we're going to move to using this ReAct agent, reasoning and act agent, to allow the LLM to start making autonomous decisions and be able to have access to tools. So what we will now do is we're going to do a quick install. So I'm going to do a pip install Langchain hub. I'm going to explain to you why we're going to need that in a second, but essentially I just want to get access to a prompt template. So rather than using the Who is Katy Perry prompt template, what I want to be able to do is pull a prompt template from the internet. And in this case, the prompt template that I need, which is the ReAct prompt template, that is going to come from Langchain Hub. Don't worry, we are going to break down exactly what that prompt template looks like a little bit later on. So let's come back into VS Code for a second, and we're going to change a few things. So the first thing is I'm going to get rid of this prompt template from template here, simply because I want to replace that with the prompt template that we're going to pull from Langchain Hub. So to do that, I'm going to type in hub.pull, and then I'm going to pass in hwchase17. So actually, that is the organization space of Harrison Chase, the creator of Langchain. And then specifically, we want to access the ReAct prompt template. And again, you've seen the squigglies here for a second. So one of the things I'm going to need to do is put in from Langchain import hub, and then that will give me access to this prompt template. We'll take a look at that in a second. Now, the next thing I want to be able to do is I want to specify the tools that it can use. So in this case, we're not going to provide any tools just now. So I'm just going to set the tools as being an empty array. Later on, we will put in that system time tool that we defined a little bit earlier. So once I've done that, I can then construct my ReAct agent. So I'm going to say agent is equal to create ReAct agent. And as you can see, we've got some squigglies in there. So I'm going to have to import my create ReAct agent. So to do that, I am going to put from langchain.agents, and then I am going to specifically import create ReAct agent. And I'm also going to import agent executor because I'm going to need that a little bit later on. So I'm going to say create ReAct agent, and then I'm going to pass in the LLM, which is going to be GPT-4, just as I did before. I am going to pass in my tools, and then I'm going to pass in my prompt template, which at the moment is going to be the prompt template that we're going to pull from Langchain Hub. And now what I'm going to do is I'm going to get rid of this output parser and this chain for a second. And now I'm just going to declare an agent executor, and I'm going to set that being equal to agent executor. And again, I'm going to pass agent is going to be equal to agent. So this is the ReAct agent that I just created a second ago. Again, similarly, I'm going to set the tools is going to be equal to tools. And then I'm just gonna mark it as verbose as equal to true for just now because I want to be able to see the output. Once I've done that, I can just get rid of this result chain dot invoke, and then I can say agent underscore executor dot invoke. We can get rid of the print because I put verbose mode in. Input is going to remain the same, and I'm going to set the query. So if we just really look at what we've done here for a second, I'm loading my environment variables as I did before, so it's got my open API key. I'm setting my LLM being to GPT-4, so it's the exact same as I did earlier. The query is what is the current time. That is going to work in combination with the prompt template. I will show you what this prompt template looks like, and that prompt template is being pulled from Langchain Hub, and it's specifically in the hwchase17 ReAct repository there. That's where it's coming from. I've got no tools at the moment, and then when I create this ReAct agent, so it's a special type of agent, I'm telling it to use the GPT-4 LLM, which I just defined. I'm saying use the empty tools and use the prompt template here. And then I'm going to pass this into this agent executor, which is going to execute the agent that I specified. And then finally, I'm going to do the invoke. So I'm saying take that agent executor that we've just defined, go invoke the agent, and then pass in this query, what is the current time? And that will get munged together with this prompt template that we talked about here. So if I just run this, obviously it is going to fail because we haven't got a tool there just now. So if I run my python hello langchain.py one more time, you can see now is entering that new executor chain exactly what we did at the beginning of this. It says I need to check the current time in my current location. Very good. Action, use a tool device that can display the current time, such as a smartphone. So it started to hallucinate because I haven't given it a tool. It doesn't know what to do. So it's just hallucinating. And then finally says, I'm sorry, I can't provide the current time, because it doesn't know any tools. It doesn't know what to execute. So it just can't answer the question. So let's fix that. Let's give it a tool that it can actually implement. So let's come back into VS Code for a second. I'm going to create a new folder, and we're going to call this tools. And then I'm going to create a new file, and we're going to call this system_time_tool.py. So to create a tool which returns the time, we would just use the system time from the datetime library in Python. So to do that, I'll just import datetime. And then I am going to create a new function called check system time. And then I'm going to expect a variable called format, because I want the LLM to be able to send me different formats. I could want it to just get the time or the date or whatever, but I will give that a default format. So in this case, it will return the full year, month, and time there. So once we have done that, we can then just define our time. So I'm going to get the current time. I'm going to put it in a variable called current time, and we will just call datetime.datetime.now, and that will get the current system date time. Now to format it, I will just have a thing called formatted time. We will set that equal to current time dot stir f time. And then we'll set that to the format that is being passed in. So if the LLM decides not to pass in a format, it will use our default format there, but otherwise it's going to use the formatting that we have. And then we're just going to return formatted time. Now, the problem that we've got here is, of course, I have got this wonderful check system time, but Langchain won't know what to do with that. So what we need to do is actually decorate that up a little bit. So I am just going to pass in a decorator called tool, and to be able to use that, I'm going to put in from Langchain .agents, and we will do import tool. Now there's a little bit of magic that goes on with this tool decorator, and that magic is it will essentially pass out in a nice formatted form the name of the function, which is check system time. It will allow it to have access to the argument type, so in this case formats, but also it will look at the description of the function. So actually I just need to provide a nice little description here. So I'll say returns the current date and time in the specified format. And this is really important because that is going to be made available to the LLM to be able to figure out what this tool actually does. So a really good description here is going to help your LLM out. So now that we've defined that, I can come back into my original Langchain file, and we can type in from tools. Remember, it was in my tools folder, system time tool, and we're going to import check system time. Just to save a little bit of space, I'm going to remove this stuff that we don't need anymore from the top there. And then what I can do now is I can just pass in check system time into tools, and that will now be passed through to the ReAct agent that I'm creating, and it will also be passed through to the agent executor. So now, if I come back into my terminal and we run our hello Langchain one more time, then it's going to have access to the tool. So as you can see here, it says I need to use the check system time function to get the current time. Action check system time. There is the format, so it's aware of the arguments that we've seen. Passes through the time, so it's obviously executed the tool, passed the time through, and then it's been able to come back with the answer. So essentially what this has done is use this system time tool. It's understood this description, it's understood these arguments, it's understood the name, and then it's been able to use this tool. Because what we have said is, we said here are tools, again remember agents are autonomous, here are tools that you can use to solve this problem. And in this case I wanted to solve the problem of what is the current time, and it's figured out it can use that check system time tool that we just created to solve that problem. Now, if I wanted to, I could do some variations. I don't need to just ask it what is the current time. I could actually be a little bit more fun in what we ask. So I can say, what is the current time? Just show the time and not the date. Now, what that will do is if we execute this one more time, is it will then allow the LLM a little bit of options, and hopefully we should get a response that isn't got the date there, but actually returns the time. So you see the final answer is the current time is 16:45. So if we look at this, I need to use check system time function to get the current time. However, the default returns both the date and the time. I'll need to adjust the format to only show the time. This is really cool. It uses the action check system time, but because it understands the format, right, it knows there's an argument which is the format argument, and then rather than passing through, allowing the default to run through, it's actually passing its own format, H, M, and S. So it's actually, when it makes that call to our system time tool, it's telling it the format to use, and then it's coming back with the answer 16:45. So you see, rather than date and time, and then it says, I know the final answer, and it says the current time is 16:45. Really cool. So this is how these ReAct agents work. Very, very cool. So let's give it another example. So rather than returning the time, I think what we will do is get it to tell us the time in New York. So we'll say, what is the current time in New York? Now, of course, it won't know where it is just now. We haven't returned that in our system time, so we're just going to tell it you are in London. So it knows when it calls the system time piece that it's getting it from London. So now if we run this one more time, hopefully it should be able to do the calculation manually and figure out from its own knowledge base that New York is 5 hours ahead of London, and then come back with the answer. So you can see here, I need to check the current system time in London. It's reasoning and then convert it to New York time. Since London is generally 5 hours ahead, I'll need to subtract 5 hours from London time. So it's called check system time. Yeah, it's passed in the time here. Again, it doesn't need the date. Current time is 16:47. To get New York, I would subtract 5 hours. So action, so rather than using a tool, it's just going to do it itself, and then it's going to come back with the answer. But as you can see there, it's failed to come back with the answer. I cannot provide the time conversion. It's terrible. You know, again, maybe if I run it again, it will do this. Let's see if running it a second time will come back with the answer. The nice thing is we could just introduce another tool, which could be a calculator, and then it could do that calculation for it. So rather than it having to try and do the calculation itself, it could just use a tool. And there you go. This time, second time of running, it's suddenly got more confident in its abilities to do calculations, and it's telling us the time in New York is 11:48. And again, that's a great demonstration of why tools become important, because if I gave it a calculator tool, rather than it trying to figure it out itself, it could use the calculator tool as well as the system time tool. So, okay, let's start breaking this down a little bit more. This isn't just about executing agents. This is actually about understanding how this works. So what we are going to do here is we are going to take a look at what this magic prompt template actually is. We understand prompt templates from before. We created one with the Who is Katy Perry one. We will go to smith.langchain.com/hub, that is Langchain Hub, and then we'll paste in HWChase17 ReAct. So we are going to see the prompt template. So if we look at this, answer the following question as best as you can. You have access to the following tools. You see that just what we showed earlier, there is the substitution variable, which is tools. So we're passing in tools. Remember what we did over here? We're passed in tools. So in this case, tools is check system time. Use the following format: question, the input question you must answer, thought. So it's actually telling it how to do reasoning, action, action input, observation. So this is the format. So we're telling it how to reason. And then it says to come back with the final answer. And then, it's telling it to kick off, passing in the input. So in this case, what is the current time? And then thought is using this thing called an agent scratchpad. So if it wants to sort of write some notes, the LLM wants to write some notes, it can do that. Now, if I wanted to, what I could do is rather than pulling the prompt template from the hub, I could actually just have that hard-coded locally. And actually, there's good reasons to do that. I'm not a big fan of having external dependencies that could change from underneath me. So actually, bringing that prompt template locally into my own project is maybe not a bad thing to do, and then I'm in control of my own dependencies. So to do that, I'm just going to copy this, and then what we will do is I am going to create a new file. We will call this ReAct template .py, and we'll do a from Langchain underscore core .prompts, and then we'll import prompt template, and we'll create a new function. We'll call it get ReAct prompt template, and then I'm just going to do a return prompt template dot from template, exactly as we did with the Katy Perry example. And then I'm just going to put in 3 quotes here. I'm going to paste all of this in, and then we will just quote it off there. And as you can see, it's just going to return that entire prompt template. Now, if I wanted to, I could now just remove the Langchain import hub. So that is now gone. And I can now just do a from ReAct template import, and we call that get ReAct prompt template. And I can get rid of the hub.pool, and I can replace that with my get ReAct prompt template. And now, rather than going to the hub, I'm just pulling my ReAct template in this hard-coded format from here. And of course, if I wanted to, I could just rerun that one more time. And of course, it's going to continue to work because I'm using the ReAct template from my local machine as opposed to using the pool from the hub. So there you go. It's coming back with final answer. The current time is New York, 11:54 and 55 seconds. So I'm no longer pulling the prompt template from the hub. I am just using my local hard-coded version of that template, and it's coming back with the answer. But I think we can go further than this. I don't think we necessarily need to trust what's going on with the agent. If we want to, we could come back to just executing this as default prompt templates and see how this works. Let me show you what I mean. So we're back to our hello Langchain. What we are going to do now is we're just going to comment out the this lot here. We'll come back to that in a second. And we're going to put back in the same format for executing prompt templates as we did before. So what I'll now do is just paste in the code that we wrote out earlier, which is using the chains and the output parser. So I'm setting the output parser is equal to stir output passer. I'm setting the chain is equal passing in the prompt template, which is going to be the same template that we had before, this ReAct prompt template here. I'm going to pass in the LLM, which is GPT-4, and then I'm going to go back to my stir output parser, and then I'm going to invoke the chain. Now you see the squigglies on stir output parser, so I'm just going to need to re-import that back in. Now, of course, if we look at the ReAct template, there's a few substitution variables that we don't have. So you see it's expecting tools, it's expecting tool names, it's expecting input, and it's expecting agent scratchpad. So what we are going to do just now is just let's manually set these in just now. I'm going to not put any values in at this point. I'm just going to put in things like tool names. I'm going to set it to blank value, so just empty strings for just now. But I just want to have all the right variables in place. So I'm going to put agent scratchpad, and we will set that to equal to empty string. So now if I run this one more time, we come back into our terminal, we'll clear this. Rather than running the agent, we are now just running a standard LLM query here. So let's run Python hello Langchain and see what happens. So as you can see there, obviously I am not using the agent executor at this point. But you start to see the remnants of this ReAct template. So it's doing the reasoning itself. I'm just doing a single prompt here. So you see, I need to find out the current time in London, then calculate the time in New York based on the time difference. So that's actually coming, that's just a pure GPT-4 LLM call using that ReAct prompt template. Action, so it's learned this format. Use a tool or app to check the current time in London. It doesn't know a tool. action input, NA, observation. So again, it comes back with final answer to current time, New York as insert calculated time. So it's not what we want, right? But you can see that the reasoning is coming from the LLM, right? But we can shape that further, because actually what we haven't done at the moment is we haven't given it access to the tools. So let's do that. So what we now need to do is inject the tools into that prompt template in the same way as the agent was doing. So we're going to do that manually. So to do that, we need something that's going to give us the definition of those tools. Remember, in that prompt template here, it's got two variables. One is tools itself, which is essentially going to have the name of the function, the arguments, and the description. And then it needs a list of the tool names that it needs to provide. So we need to pass through the tool descriptions and the tool names into this prompt template. We need to inject it in. So I need something that can describe this tool. Now, Langchain does have a very useful module that does that. So if we import from Langchain tools.render, if we import specifically a thing called render text description, then that's going to allow us to describe those tools. So underneath here now, what I'm going to do is I am going to have something that actually lists out those tools. So I'm going to create something called tools list, and we are going to set that equal to render text description. And then what we will then do is we will pass in a list tools. So we're going to pass in a list of our tools. And then obviously I want the tool names as well. So I'm going to pass in tool names, and we're going to essentially just do a list of the names. So we are just going to join together t.name, and we'll do a for t in tools. And that will essentially just loop through all the names in the tools. We'll do a join and it'll comma separate that. Now, if I take that here, we'll put that before the result. Now, before we go and invoke this, what we want to do is just actually look at what comes back from this tools list and these tools names and how it looks within the context of the prompt template. So I am just going to print out, I'm going to call the format method off of the prompt template. I'm going to pass in the substitution variables. So it was expecting input, tools, tool names, and agent scratchpad. I'm going to say agent scratchpad is equal to blank just now, but we're going to pass in those tool names, and we're going to pass in that tools list. We're going to pass in that query, what is the current time, and we're just going to see what that actually looks like. So I'm just going to run a Python hello Langchain, and you can see here, again, I'm not invoking just now, but what's actually happening in the prompt template, it says answer the following questions best as you can. You have access to the following tools. Check system time, the name, check system time, format. So it's actually accessed all the arguments of our function, and then it says returns the current date time in the specified format. So if we come back into our tool, our system time tool, you see it returns the current date and time in the specified format. So that's what this tool decorator is doing. It's giving access to this render text description. It's describing what this function actually does. So if I changed one of the values in here, if I said formatty, and then we just run that again, you're going to see that it now comes back with in the list, returns in the specified formatty. So this is really important, this comment over here, but we'll just set it back to being format. So now that we understand what's going on here, I can get rid of this print statement, and then we can invoke this chain and print out the result. And what we are going to do now is we're going to pass in the tools names to the tool names variable, and I'm going to pass the tools list here as well. So now I'm going to invoke the chain just as I did before, and I'm going to pass in the query, the tools names, the agent scratchpad. But of course, I'm not running as an execute, I'm just doing a one-time execution. So let's clear this, run this one more time, and there we go. You can see it's coming back. I need to find the current time. However, I'm in London, system time will reflect the London's time zone, blah, blah, blah. So it's doing that reasoning, and then it's using the action, check system time, action input is this, and then observation 2:30. Now, as you see in my clock there, it's 5:10. So the big thing that's happened here, it's got as far as this, and then it starts to hallucinate. So it's hallucinated the time because it's not executed the tool. I've given it a list of the tools it can use. I can give it a list of the tool names, but we haven't actually executed the tool, right? Because the agent framework in Langchain is actually executing the tools. We would actually have to manually execute the tool. We'd have to have something that does this. But regardless, it thinks it's got the time at the moment. So it's hallucinated 2:30, and then it's done the thought, and then it's went around a couple of times, and then it's came back and said the time is 9:30. So it's done 5 minus 14:30. So you start to see how the agent is working now, right? It's got as far as here, then it would have executed this. Once it's put the right observation in, then it can continue on from over here and come back with the final answer. So we obviously, in order to stop it hallucinating, we actually need to stop it at this point so that it can execute the tool. Let's stop it on that observation, right? So to do that, I'm going to come back to my LLM here, and you can see model is equal to GPT-4. And what I want to be able to do is tell the model to stop whenever it sees the text observation. So to do that, I just need to pass in model quarks, and then I'm just going to set stop is going to be equal to a new line observation. We save this, and what should happen if we come back into our terminal, when it does the action input here, if it sees the text observation, this token here, it should stop. So let's clear this and then run this one more time. And you can see it says, I need to check the current system time, adjust it in New York's time zone. New York is typically 5 hours behind London. Action check system time, action input. And because it stopped at that point, what we can now do is execute the tool and then insert that in. And that's how these agents are working. So it actually puts a stop as soon as it sees observation, and then it can go and execute the tool and then place the observation manually into the prompt template and then let it continue on. So let's do that. So what we will now do is I'm going to take the prompt template, which remember is going to get injected. I'm going to set it equal to the prompt template, and then I'm going to inject some results within here. So if we come back here for a second, so if you remember, what we are going to do now is I'm going to insert all of this in here. So this is simulating what the agent actually does. So it's just taking the history and then it's injecting it in. And now I could just do observation. So it will take the, remember when it's run this, it knows what the format of the tool is. So you see action, input is H, M, and S, and it says action check system time. So I could just execute the tool. So I could go find my check system time tool, pass in the input, execute it. And then what I will do is pass in the time. So in this case, it is 17:20. So we'll just say it in 0 seconds. And then finally, what I want to do to help it along its way is I want it, if you remember, it's following this format of question, thought, observation, thought. So once it's done its observation, I want it to do a thought. So I am just going to pass in here a new line, and then I'm going to pass in the word thought there. And then I'm just going to let it continue on where it left off. So if we just run that one more time, you can see it's going to execute off, and it's essentially going to continue on where it left off. So it's saying here the current time is 17:20. New York is 5 hours behind London, so I need to subtract 5 hours from this time. And then final answer 12:20, and then it continues. So all you really need to do is concatenate the beginning to the end. So if we think about really what agents are doing, they're going through a loop. They're calling the first piece. If they see observation, they're going to stop. They're going to take the inputs, the action. They're going to execute the action. They're going to concatenate the history, put it back through the LLM in a loop, and then keep doing that until it gets an answer. And then eventually when it gets the final answer, it's going to output it to you. And that is exactly how ReAct agents work.